Here are some examples about multiplying and dividing monomials. Problem 1. Simplify 5ax squared times 7bxy cubed. So first let's write this out. 5ax squared times 7bxy cubed. Now to multiply these, we first want to multiply 5 by 7 since those are just numbers. So we'll have 35. Then let's look at the variables. So a only occurs on the left side, so we'll just write a. And then next we have x squared in the left side, but there's also an x on the right side. X squared times x is going to be x cubed, since there'll be 3 of them total. And then b only occurs on the right side, so we just have b, and y only occurs on the right side, so we'll have y cubed. And the final answer is 35ax cubed by cubed. Problem 2. Simplify 6x times x cubed times x squared to the 5th power. So first let's write this out. 6x x cubed x squared to the 5th. Now first we get rid of the 6. 6 is the only number here, so the coefficient of this will be 6. Next we need to figure out these powers of x. Let's first look at the last term. So let's leave the x and the x cubed and look at x squared to the 5th power. Using the rules of exponents, we know that raising x squared to the 5th power will give us x to the 2 times 5, which is 10. So we'll have x times x cubed times x to the 10th power. Now again, using the rules of exponents, we know that multiplying powers of x will be adding the exponents. So our final answer will be 6x to the power 1 plus 3 plus 10, since those are the powers of x we have to multiply together. 1 plus 3 plus 10 is 14. So the final answer is 6x to the 14. Problem 3. Simplify pq squared divided by 4pq cubed. Let's write this out. pq squared divided by 4pq cubed. Now before we divide, let's simplify the numerator. So pq squared is just going to be equal to p squared times q squared. So we divide this by pq cubed. Now dividing powers of something is equivalent to subtracting their exponents, so we'll get just p in the numerator, since 2 minus 1 is 1. And then we'll have q to the power minus 1, since 2 minus 3 equals minus 1. And then this divided by 4. But we know that q to the minus 1 just means 1 over q, so we can rewrite this as p over 4q. And that's our final answer. Problem 4. Simplify 12x to the minus 3 times xyz to the 4th, all divided by 2z to the minus 2 squared. First I'll write this out. Now this one is a bit more complicated than the ones we've seen already, but the same methods apply. So first we want to simplify the numerator. First we just have 12, and then let's look at the x terms. We're going to have an x to the power minus 3, and then the xyz to the 4th will give us an x to the power 4. So if we multiply those together, we'll get x to the minus 3 plus 4, which is x to the 1, just x. And then the xyz to the 4th term will also give us a y to the 4th and z to the 4th term. So that simplifies the numerator. Now let's look at the denominator. We have 2z to the minus 2 all squared. So that means we're going to square 2 to get 4, and square z to the minus 2, which means that we multiply the exponents and get z to the minus 2 times 2, which is minus 4. Finally, we can divide. So first, dealing with the numbers, we'll have 12 divided by 4, which is 3. The x terms will give us just x. The the y terms will give us y to the fourth, since there's no extra y terms in the denominator. And finally, we have z to the fourth divided by z to the minus fourth, which means that we'll have z to the power 4 minus minus 4. The minus signs cancel here, and we get 4 plus 4, which is 8, giving us 3xy to the fourth z to the eighth as our final answer.